Okay, today we're going to talk about the structure of matter. And we know that matter is made up of atoms. So let's talk about the number of different types of atoms that are out there. This is really the same question as how many elements are there on the periodic table, which we'll be talking about later on. Turns out that there are 92 naturally occurring atoms on Earth. So there are 92 different elements. And what we mean by an element is simply a material that's made up of only one type of atom. So for example, if you have oxygen, it's just made up of oxygen atoms. Or if you have something made of aluminum, it's made up of just aluminum atoms. So there are 92 different naturally occurring elements on Earth, so 92 different types of atoms. We can make about 20 additional ones in the laboratory, but they're radioactive, and that simply means that they only last for a fraction of a second and then they decay. They basically change into something else. When we think about things that are not elements, notice that most of the items that you probably have around you right now are not made up of just one element, but are made up of multiple elements. So if you think of something such as water, well, water is made up of two different types of atoms, or two different elements, hydrogen and oxygen. Let's take a look at what is inside the atom. Originally, atoms were thought to be indivisible, but it turns out that atoms are in fact made up of smaller constituents. And the three fundamental particles that you'll find inside an atom are electrons, protons, and neutrons. And if we look further at the structure, what we find is that the protons and the neutrons are bound together in the nucleus of the atom. And the electrons then surround the nucleus. One of the things about this picture, and this is kind of a typical picture you might see that represents the structure of an atom, it's important to understand that it's not to scale. And what I mean by that is it turns out that the space taken up by the electrons is actually much larger than the space taken up by the nucleus, and I'll talk more about that in a second. So let's talk about how big atoms are. Obviously, we know that atoms are very small and we can't see them. Different atoms, different elements have different size atoms, but they're all roughly about 10 to the minus 10th meters in radius. Okay? So atoms are extremely small. Let's take a look at the following question. If an atom were enlarged so that the diameter was the size of a football field, how big would the nucleus be? So in other words, picture our electrons going around the atom and that atom being blown up to the size of a football field. So the question is, how much of that space of the atom is actually being taken up by the nucleus? Well, it turns out that at this scale, if we enlarge an atom to this scale, the nucleus would only be the size of a pinhead at the 50-yard line. And so the most important thing to get from that is that atoms are mostly empty space. So we have these electrons circling the nucleus in some way, and the nucleus is very, very small right in the center. Okay, so atoms are mostly empty space. Let's take a look at the periodic table. The periodic table is used to organize the elements. And when we look at the periodic table, we talk about groups and periods. So columns are referred to as groups. So there would be group number 1. And then rows are referred to as periods. You may wonder, why is the periodic table ordered the way it is? And the reason, as we'll talk about more in a moment, is that it's ordered based on the behavior of the elements. If we look at the periodic table, we'll see that each element has an atomic symbol, and that will be 1 or 2 letters. And an example here would be, for example, there's carbon. Another example I mentioned is Ag, which is helium. You'll notice that only the first letter is capitalized. The second letter is always lowercase. And that's simply because we need to differentiate between different elements and then molecules, which are combinations of elements. So if you saw CO, both letters capital, that would stand for carbon and oxygen, which is what carbon monoxide is. If you see a capital C and a lowercase o, that means cobalt. Okay, so how is the periodic table organized? Why does it have this shape that it does? The periodic table is organized based on the chemical properties of the elements. And Mendeleev was the first person who came up with the basic structure of the periodic table. He didn't really understand what was going on inside individual atoms. He didn't even know that there were such things as protons, neutrons, and electrons. So he organized the table based on behavior. So for example, if I look at this group here, that column, all of the elements in that group have very similar chemical properties. So for example, all of those elements are gases, and these are what are referred to as the noble gases, which means that they don't interact. Just like kings and queens don't interact with everyday people, the noble gases don't interact with other elements. Okay? Another example, the elements in this group are very reactive. Okay? So the way the elements react chemically is what determines which group they go into. One question that I always had when I was first learning some of the elements of chemistry is this one. Why are there two separate rows on the bottom of the periodic table? As we just saw in the last couple slides. And the answer for that is really kind of simple, and that is it's simply because the periodic table would not neatly fit on an 8.5 by 11 sheet of paper. So when the periodic table is printed, usually what happens is these two rows are simply printed down below, and the other two halves are brought together. Okay? And so that's why the periodic table has those two rows that don't seem to fit down at the bottom. But really, this is what the periodic table would look like if you drew it out completely. Let's take a look at what are the most common elements. And in order to answer that question, the first thing we have to say is it depends on where you look. So if you were looking at the universe as a whole, what you'd find is that by far the most common element is hydrogen. Okay? And if you look back on the periodic table, you'll see hydrogen, which is represented by the letter H, is the first element in the periodic table. And it turns out that over the entire universe, the universe is mostly made up of hydrogen. So the situation we have here on Earth is actually is not common throughout the universe. If we looked in the air, we would find that air is made up of just a few elements. For example, air is mostly made up of nitrogen. Nitrogen is 78% of the air. Oxygen only makes up 21% of the atmosphere. And you'll notice that that adds up to 99%. There's just a little bit of percent left over, and all the other things that are in the atmosphere, like carbon dioxide, etc., just make up a very small part of the atmosphere. All right, well, let's look at something that's more relevant to you as a radiologic technician, and that is, what are the elements that are common in the human body? It turns out that by far the most common element in the body is oxygen. And of course, one of the places that that oxygen shows up is in water molecules, in H2O. So oxygen is the most common element in the human body. Then we have carbon at 23%, hydrogen at 10%, nitrogen at 2.6%, and everything else is less than that. And of course, we have lots of trace elements in the body, but you'll notice that by far the big ones are oxygen, carbon, hydrogen, and nitrogen. If we look at the elementary particles or fundamental particles that we find inside the atom, we find that protons have a positive charge, neutrons have no charge at all, and electrons have a negative charge. And as you know, opposite charges are attracted to each other, and because the nucleus of the atom has overall a positive charge because of the protons in the nucleus, and the electrons have a negative charge, that's what keeps the atom together. The electrons are attracted to the nucleus, and so as they circle around the nucleus, they don't fly away, but they stay attached to that atom under most circumstances. Much in the same way that the Earth continues to revolve around the sun because of the gravitational attraction between the sun and the Earth. Atoms in general are electrically neutral, and that's because in a standard atom, the number of protons and the number of electrons is the same. So for example, with oxygen, oxygen has 8 protons and 8 electrons. Okay. Now, it turns out, as we'll talk about later, an atom can lose an electron. It can be ionized, and that means it has an electron knocked out. But in the standard state, atoms are neutral. Let's go in and look at a little more detail at the nucleus of the atom. We've said that the nucleus is made up of protons and neutrons, and we collectively call those nucleons. We also give a special name to the number of nucleons, and that is the atomic mass number. Atomic mass number is represented by the capital letter A, and it simply represents the number of protons and neutrons inside an atom. One of the things that we've already talked about is the fact that the nucleus of an atom is very, very small, that atoms are mostly empty space with the electrons buzzing around in what's essentially empty space, and then the nucleus being located in a very small space at the center of the atom. One of the other things that's interesting about atoms is that because protons and neutrons are about 2,000 times more massive than electrons, almost all of the mass of the atom is located right there in the nucleus. The electrons have almost no mass compared to the protons and the neutrons. So let's take a look at what differentiates one atom of an element from another. It turns out that it's the number of protons in the nucleus that determines the element. And we give the number of protons a special name. We call that the atomic number. Notice that that's different than the atomic mass number that we just talked about. The atomic number, which we represent by the letter Z, represents the number of protons in the nucleus. If you look at a chart of the periodic table, you'll notice that there are always these numbers on the periodic table, and those simply correspond to the atomic number. So again, you'll notice the first element in the periodic table is H, which represents hydrogen. Hydrogen has 1 proton. Helium has 2 protons. Lithium has 3 protons. Beryllium has 4 protons, etc. So for example, here's carbon with 6 protons, oxygen with 8 protons.